You kneel in the tall grass, hands raw from digging for roots, sun beating down, sweat trickling down your back. Something brushes your ankle, a whip-quick flash, sharp, sudden pain. You look down, 2 red pinpricks welling blood. Your heartbeat hammers. You recognize the pattern left in dust beside your foot. A viper, venom creeping upward, 1 cell at a time. Today, you call emergency services. They track 7,000 venomous snake bites per year in the United States alone. Anti-venom arrives packed in refrigerated syringes. The surgeon's tools are sterile. Most victims survive. But in the Paleolithic world, on the grassland edge of Lake Eyasi, Tanzania, 30,000 years before you, there were no doctors, no glass vials, no antidotes, no phone. In a world with no modern medicine, 1 bite could define fate. Yet anatomically, modern humans spread to nearly every continent covered in dangerous snakes. Every step carried risk: African puff adders, Eurasian vipers, Indian cobras, Australian taipans. Fossil evidence from Border Cave in South Africa tells us humans lived and died side by side with them for tens of thousands of years. Most did not survive, but some did, and this changed everything you know about ancient life, the limits of your body, and the people you depend on. Because the way humans survived snake bites is really the story of how you learn to survive together. In 2019, herpetologist Harry Green published a study on hunter-gatherer survival rates after snake bites in Brazil's Amazon basin. He found that even in the 21st century, groups without hospitals still survive up to 60% of bites if they act together fast. But the story goes further back than any modern numbers. Now, ask yourself, where do you find hope, knowledge, or even defiance when venom is already in your veins? To understand, you have to look back to stone tools, bone necklaces, and cave healers across 99% of human history. Because this changes everything you thought you knew about danger, care, and the body you live in now. In 1960, archaeologist Ralph Selecki revealed a grave deep inside Shanidar Cave in northern Iraq. The skeleton, known as Shanidar I, belonged to a Neanderthal man who lived roughly 50,000 years ago. His bones tell a brutal story: a crushed left eye socket, a withered right arm, and a long-healed foot fracture. Yet the most striking detail isn't his injuries, it's his survival against the odds. Around his remains, researchers found traces of wild yarrow, marshmallow, and ephedra, plants still used in folk medicine today. Some paleobotanists, including Dr. Arlette Leroy-Gorhon, argue these were used in Neanderthal healing rituals. Others are skeptical. What they agree on is this: Shanidar I lived years after his injuries. Someone must have helped him. Someone treated the wounds, carried him, fed him, learned which roots soothed the pain and which ones didn't. These patterns, herbal knowledge, social care, surface again and again in the ancient record. The earliest known written treatment for snakebite appears on the Ebers Papyrus, a medical scroll from ancient Egypt over 3,500 years old. It lists more than a dozen anti-venom plants and procedures: garlic paste, honey, resin, repeated incantations. Other scrolls urge the application of magical knots or snake stones. While many recipes lacked modern efficacy, some ingredients did offer mild antiseptic or pain relief effects. But ancient survivors relied on more than herbs and chants. In 2017, a team at the Chinese Academy of Sciences led by Dr. Qian Zhang discovered something unexpected in human DNA. Certain genes in populations exposed for millennia to venomous snakes, such as the Bai people in Yunnan, carry genetic variants that make their blood proteins harder for venom enzymes to break down. In Australia, research by Nick Casewell and Brian Fry found similar gene adaptations among First Nations communities exposed to taipans and death adders. You rely on pharmacy shelves and 9/11, but your genome remembers. Over millennia, the survivors, often by chance or by care, passed microscopic defenses forward. Not absolute immunity, but just enough edge. Except there was a problem. No matter the ritual, the plant, or the gene, many snake bites still ended one way. In 1993, anthropologist Daniel Moorman cataloged Native American remedies from over 50 tribes. Despite thousands of years of trial and error, many methods offered hope more than cure. At the Gladysvale Cave in South Africa, excavations led by Lee Berger uncovered evidence of repeated human occupation dating back at least 205 years. Analysis of bones from the site revealed puncture wounds with signs of infection. Cleaning, binding, and herbal poultices sometimes fought bacteria, but the arrival of venom carried a different calculus. Without anti-venom, survival turned on luck, the bite's location, the species of snake, and the speed of help from others. All the knowledge and cooperation in the world rarely guaranteed life. In the Upper Paleolithic, in sites like Gow's Cave in England, patterns of trauma and recovery uncovered on ancient bones show this hard truth. For every person who made it, many did not. And those who survived did so only because their group recognized something essential. To survive, you must be more than just an individual. You walk through parks, gardens, or forests, rarely looking where you step. Hospitals are near, anti-venom is real, danger seems less immediate. But 100,000 years ago, every step was a question. Will I make it back? Snakebite survival was never about being unlucky or even especially brave. It was an ancient negotiation written in scars, in plants chewed before you were born, in genes sharpened by loss and by trust. You survived because others pulled you back, spat venom from your wound, or simply stayed awake to keep you alive through the night. Your body remembers. Every risk, every pain, shared or faced alone, threads you back to the people who survived before you, one uncertain step at a time.